Video will discuss about the design steps of gusseted plate. So before going to start design of gusseted plate, some few things we have to understand that the difference between gusseted and base plate. I say already the gusseted plate design is almost 4 steps the same as your slab base. So if you remember these steps you have to practice means, so 4 steps you can write without any doubts. So now the main difference in the design of base plate, what happened, we only designing the base plate and connections, but here what happened, here we did design base plate, we have to design gusseted angle, we have to design gusseted plate, means we have to gusseted plate. So here we have designed mainly 3 elements. Which are the 3 elements? One first element is gusseted base, okay, second is gusseted angle and gusseted plate. These 3 design will consist of gusseted design of gusseted plate or gusseted base. So now we will start with the first is, you already know, I already focus on this is the, we can say, initial steps. So first you have to read the question and write down the given data. That is, given data is very important for any type of problem. If you understand the question, then only you can able to write the given data. Once you write given data, then you focusing on second step is already say sectional properties of the given section by referring steel table. It may page numbers are different, so we require only 4 properties there. We not require all the properties like Ix, Iy, Ry. We require only the few properties that is same as your design of slab base. We require actually by referring steel table you have to take only 4 properties. That is, you have to need to calculate need to note down h value, or h we can say h height, or you can say depth small d, okay, h or small d. This is the first. Second thing, we require width of the flange, or you require b. In the steel table they indicate only by b, width of the flange, that is indicated by b. Then we require thickness of the flange, that is indicated by tf, and lastly and finally we require tw, thickness of the web. These all 4 properties we require from the steel table. Remaining things will not require. Don't waste your time by writing other properties, is a waste of time and you lose your marks in the examination. We require only 4 properties. That 4 properties same as your design of slab base. So first one is given data, second is your sectional properties from the steel table by referring steel table. So now after the completing steel section properties, we will go for step number 3. We have to calculating the bearing strength of concrete. Bearing strength of concrete, how we calculate, you already know by referring page number 46 of IS 800 2007. You can get the value of bearing strength formula is 0.45 FCK. I already say you can't able to take 0.6 because this is for maximum load cases, and in the problem they never mention it is a maximum limit cases or maximum loads. So we'll take same as 0.45 FCK. So you'll get the value of bearing strength of concrete. Okay, so now fourth step is, this is also same as your design of slab base. So fourth step also same as your design of slab base. So you have to calculate the area required for the base slab. Area required for the base slab, that is we already know, A, capital A required divided is equal to factor load divided by bearing strength of concrete. Bearing strength of concrete we already calculated in step 3, that is only I'll put in the values in the denominators. So you get Pu divided by bearing strength of the concrete, and here we require factor load. We not taken working load, we are always taking factor load. So factor load is not given the problem, you already know, you have to multiply with axial load into 1.5, so sorry 1.5, so you get the factor load. That factor load indicated by Pu divided by bearing strength. Now up to this is the same as your design of slab base. Now the remaining things will start. So now what happened here, now we have to calculate, you have to calculate the size of the gusseted plate, you have to calculate the base plate, we have to calculate the gusseted angle. So these 3 different elements we have to design. Okay, so how we design this element? First we go to understand the thickness of gusseted plate. We are always assuming, okay, we are assuming the gusseted plate thickness, and in this record I say in the code book they not give any minimum value, but as per the experience, most of the authors they say the minimum thickness of gusseted plate should not be less than 16 mm. you have to start minimum thickness of gusseted plate start from 16 mm, not less than 16 mm. If you take less than 16 mm means your design may be wrong. Okay, so it means that you start with minimum value of gusseted plate is 16 mm. You can take more than 16 mm but not less than 16 mm. Now gusseted angle is chosen depending upon the bolting arrangement. Okay, so now this bolting arrangement I'll discuss in the next problem. I think I not draw a diagram here. Here you have to use only unequal angle. Why it is unequal angle? I just explain in the words. The angle, gusseted angle, it is connected with gusseted plate and column section, and one horizontal leg is connected with the base plate. If you want, I can show the diagram here. From this diagram you can understand here. See here, the gusseted clit angle I mentioned, but it is gusseted angle. The gusseted angle should be connected with gusseted plate and I section. And one more condition according to experience they given, the angle which is connected vertically with the gusseted plate should be consist of minimum 2 bolts, not less than 2 bolts, minimum 2 bolts. But when it is connected with the horizontal leg with base plate, that may be consist of only single bolt is enough. It means that you can't be able to provide a equal angle here, because equal angle means you can provide one bolt, you can provide equal angle. But experiences say we can't be able to prepare only one bolt because it is carrying heavy loads. So the connected leg with gusseted plate with the I section should be having minimum 2 bolts. It is having minimum 2 bolts. That's why we have to always use here unequal angle sections. Okay, have to use unequal angle section, that you clearly understand when you go for the problem. Okay, so now the thickness of gusseted angle should be same as thickness of the gusseted plate. It means that if you taken 16 mm means the gusseted angle thickness also should be same as 16 mm, but it is very difficult to take 16 mm, because the problem is when you take 16 mm, assuming when you go for a steel table according to the requirements of long length and short length is very difficult. So that's why properly what happened, you can't able to take exactly 16 mm, but near to or near equal to the 16 mm. You can take a minimum as regard maximum of 16 means you can take 15 is also near to 16 mm. Okay, that we explain in the class, explain when the solve the problem. Okay, now after that we have to calculate length of the base plate. It is also depending upon the diagram how you calculate the length of the if you go for the diagram, I just show you here. This is the length of the, okay, so what is the length here? See here, IS column is connected, that having depth of D or H. Both the side is having, there is no cover plate here. If you having cover plate also, you can mention that cover plate thickness also. If there is no cover plate, no need. I section depth plus we have 2 gusseted plate thickness, that we have to add 2 plus 2 into thickness of the gusseted plate plus 2 into the horizontal leg that is connected with the base, that is we say B, that length plus overhang. So we will get the total length of the gusseted plate. So if you see in the formula they given here, depth of this section, if it consists only I section, if it consists with thickness means plus 2 into thickness of the cover plate plus 2 into thickness of gusseted plate plus leg length, that is of angle that is connected with the base of base plate plus overhang. So overhang will assuming here the minimum overhang length is 5 mm. You can assume minimum 5 mm, not less than 5 mm. If you take more than 5 mm, it is better. If you take 5 mm also, it is okay, quite okay, but not exactly okay. You can take more than our length of the overhang. Okay, so after this we can go for assuming overhang length, will get the length of the gusseted plate. Once you get the length of the gusseted plate, okay, so now in this case we have 2 cases, connection with bolted or connection with welded. If you go for welded connection, we not require any gusseted angle. If gusseted angle is not required means length will be changed, the formula of length is changed. So depth of this section plus 2 into thickness of gusseted plate plus overhang. So there is no thickness or no length of the angle section, because directly we can weld I section and cover plate and gusseted plate directly in the base plate, so no need of any angle section. Okay, so after calculating this we have to go for width of the base plate. So width of the base plate we already know. Area required you can calculate already in the step 4. Length you calculate in the step number 5. So we'll multiply. So we know only the thing is B is unknown. So A you know, L you know. So you can calculate directly B. The value of B you can calculate from the formula. So now you have to check area provided always greater than area required. If it is there, then only it is okay. If it is no, so again you have to check by multiply L and B you got. L and B you provided is equal to L and B. When you multiply, the area provided should be greater than area required is same as your design of slab base. Now intensity of pressure you calculate, that is also same as your design of slab base. Now the thickness of base plate, the thickness of slab base formula is given in the code. Okay, but thickness of the gusseted base thickness is not given in the formula, but I modified this formula with the help of my experience. So if you remember this formula, these two formula you should remember. T is equal to C1 square root of 2.5 W divided by Fi. There also you got 2.75 into 2.5, but here I will take as 2.75. This is a modification of the formula. This formula is not available in any code book. You should refer this, you should remember this. So when you got T is equal to C1 into root of 2.75 into W into Fi. So Fi you always know, Fi is always 250, is given or not given. Okay, so this formula is not given. So now we have to need T. Capital T is the thickness of the gusseted base. So now T is equal to T minus thickness of the angle. So this thickness of angle will get from the code. And C1, what is C1? You already know. C1 is the cantilever portion or cantilever length or projection of the length. So now we got the T value. The T value should not be less than the thickness of the gusseted plate. This is the main thing. If it is less than, we can provide, I can assume directly the more thickness of the gusseted plate are same as the gusseted plate. Now this is the formula which is applicable only for minimum height of the gusseted plate, that is given by H is equal to connected length vertically, that is A, plus 2 into end distance plus pitch distance. Only 2 bolts, depending upon 2 bolts they are given pitch distance. So this is the minimum height of the gusseted plate, and this value will be changed depending upon the number of bolts which is calculated at the ends. If it is go for welding, it will be same. So there is no need of this gusseted plate. Okay, now after this we have to calculate width of the gusseted plate. Width of the gusseted plate we have to assume same as base plate width. So this is about your design steps of your gusseted plate, where we will discuss about all in details. So few things which is not able to discuss here, that is why you have to take unequal angle, that I explained in the words. Now in the problem, when you go for the problem, you solve problem, then you understand why you have to take unequal angle only. So I think this much is enough in this video. Please, okay, so take care.